Welcome everyone to the Boltathon. I'm really excited to introduce to you Rusty Russell. He is the infrastructure tech engineer at Blockstream, and he's going to be speaking on JSON Interface with C Lightning and how to write extensions.
Cool. Okay. Thank you. I assume my audio is working and you can hear me.
Yes, sir.
Yeah. Okay. That's good. Okay. I will just share my screen now. So what we're going to do, I'll wait for that to happen. Okay. I'm going to share desktop 1, share screen. Okay. Cool. Hopefully at this point you can all see my crappy screen. There we go. Okay. My top running. Okay. So we have a plan and we're going to start from like 0. So we're going to clone C Lightning. We're going to compile it. We're going to set up a test, a little test node. I'm assuming, Bitcoin's already installed. We're going to, talk a little bit about configuring it and stuff like that, because, all this stuff is really useful to see somebody else do. Yeah, it's all documented, but it is nice to see somebody actually go through it. And then we're basically going to create a little project. We're gonna create 2 of these nodes. We're gonna get them to talk to each other. So we've got a little play area to play with. We're gonna stumble across a bug and show you what to do when you hit a bug in C Lightning. And so we're gonna deep dive into that. We're gonna talk a little bit about JSON and stuff like that. And that's like the first half. So basically it's, all that infrastructure stuff and setting up and what to do and how things work. And then we're actually gonna write a little plugin. We're going to write the world's stupidest plugin. And once we've kind of gotten as far as we can with like the world's dumbest plugin, so we kind of have some idea of how plugins work, we're going to actually step up and write like a kind of a real plugin, and deliberately kind of leaving it a bit unfinished so you get some idea for like things that you could do with plugins from there. Okay. So I would encourage you to ask questions on the way through, particularly if I go through something too fast. We've got 50 minutes, so hopefully we can get through most of this. So I'm going to go into my temp directory. Hold on, I'll make this a bit bigger in case. Okay, we're going to git clone. Actually, I'm going to cheat and cut and paste this one. So if you see me looking sideways, that's because my spare monitor is over to my right, so that my cheat sheet's there. Okay, so as a general rule, C Lightning releases, we do releases, but it's always more fun to run on master, which should be reasonably stable. As a rule, I tend to run my nodes on master or pretty close to, simply because I like the extra testing. So particularly if you're doing development, it's nice to be on master. So we've got our Lightning, its master version. Sorry, what I meant is describe. We'll see where 81 commits past 070. This is the latest and greatest. Now, if we look at docs, there's a docs directory, which has a whole heap of stuff, including install. It basically tells you to, how to install on Ubuntu, and you install all these things. You obviously need Bitcoin. If you're doing development, you might want to install these things too. So you probably do want to do that. Obviously, this is my development machine, so everything's already installed. It will then tell you to configure and make. Now, I would recommend enabling developer. Enable developer. That adds you a whole heap of dev options, which can let you do weird and wonderful things to Lightning D. Which is quite useful. So we run our configuration step. That takes a few seconds, and then we build. So we make -J7 or something, which will build the whole project. It's actually not all that big, so it shouldn't take that long. It does have a few external dependencies, which it will pull in. And so that's actually what takes a lot of the time for the very first build. Okay, so while that's building, we'll talk about how we're going to do this. So by default, when you run up C Lightning, it operates out of your home directory in a .lightning directory. Since we want to run multiple copies, we're going to force it to operate out of temporary directories for the moment, so that we can run 2 of them at once. And the way C Lightning is designed is there's like a central daemon, and there's a whole heap of subdaemons. And this is done for security because each peer basically gets its own daemon after the initial handshake. And so that should anything go wrong with a specific peer, they can only really mess themselves up. They can't, mess up the other peers, at least in theory. So we get some increased isolation from that model. But that's why when you see C Lightning running, you'll see some subdaemons running, and I'll show you that as well. And it will also fire off one daemon per client that's connected. Now they're pretty lightweight, so it doesn't actually make a difference. You can still have thousands of peers without a huge problem. We can see it all building here. It's pretty verbose as it goes through. Because we've enabled development, we've got a whole heap of debug options sitting in there as well. Okay. Okay. Maybe I should have used one of my build machines that's faster than my laptop for this, but it won't actually take too long. So while it's doing that, we'll create some infrastructure. Oh, okay. As he says that, it's finished. So we do make install. That will install and use a local bin by default. I've set up permissions on my machines so that you don't have to be root to write in there. And all those Lightning things are enabled. Now, the first thing we need to do is run up bitcoind. Now, bitcoind has a reg test option, which is basically a limited test network style option. And that's great for testing on a local machine. So we fire that up. We make there a couple of directories, call them L1 and L2 for our daemons. And then we run up lightning d network reg test, and give it the lightning dir temp equals temp L1, and okay, cool. Okay, that's lightning d firing up. It's spitting out a whole heap of stuff. It's chosen itself a random, a secret and a public key, and derived a NSA style code name from it. If you're a development version, your name of your node also gets appended to the version that you're running. If you don't enable developer and configure, you'll just get a random name. Okay, so now one thing that people often do is that it's created, it's populated the temp L1 directory at this point. It's having trouble with fee estimation, as you can tell, by the way. That will happen because regtest doesn't do fee estimation when nothing's happening. If we look in temp L1, it's created a store where it holds all the gossip, which obviously just has a header in at the moment because there's no gossip on the network. The HSM secret, that's the secret that you need to keep secret, because from that is derived all the stuff that your node signs. So that 32 bytes is kind of important to back up, and something you'd expect to see. It creates a PID file that shows that it's running. It creates a database, SQLite3 database, which is pretty standard. And it has a Lightning RPC socket. And this socket is basically how the command line tool talks to Lightning D, and how any other tool that you write will talk to Lightning D generally. Okay. Now, if we look at the tree, I told you before that it's a heap of subdaemons. So it's spamming the console a little bit. We'll fix that in a moment. Okay, so here you can see Lightning D, and there's Lightning Connect D. That's the one that's responsible for both when you ask a connection to come out and when somebody connects in. It sorts out the handshake, who they are, and figures out what daemon to hand them to. There's Gossip D, which is responsible for all the gossip. It controls routing. It controls gossip about chatting about routing to other nodes, and things like pings and stuff all go through Gossip D. There's the HSMD, which is the hardware. God, what does HSM stand for? It's basically that controls all the secrets. So it does all the signing, all the cryptographic operations that require knowledge of the secret keys. And there's a pay. So there's one plugin that we ship by default called pay that actually implements the pay command, which is kind of important. And so,
hey, Rusty?
Yeah.
So one person is asking.
Thank you.
One question is, what's the advantage of using regtest over testnet?
Okay, so testnet you can't control. Regtest, I can generate a block anytime I need. So I can just tell bitcoind, oh, generate a new block. right? Which is great for testing stuff. Whereas with testnet, right, other people can create blocks. It can be significantly more difficult to create a block. People can create blocks randomly outside your control. People can fork the network, all those kind of things. So when you want that level of control, you do reg test, and it's basically your private testnet. Cool. Okay, so I mean, I tend to test on reg test, and then I just jump onto the live network. You know, testing on testnet it can be interesting if you're trying to do big tests between remote people and different implementations. But for testing the same implementation, reg test is way, way easier. Okay, so let's run up Lightning CLI now. I'll just clear out the spam. Lightning CLI. I have to tell it what Lightning Dura to talk to because it'll look in the wrong place by default. 2.1, and do get info, right? This is the information about our node. You can see its ID here. That's its public key. We have the alias. Each node gets an alias and a color. You can choose those. They're completely, you know, you can copy other people's. There's no security around that at all. The color by default, as you can tell, is the first. It's red, green, blue, and it's taken from the first 3 bytes of your ID. Shows how many peers we have, how many channels, which are all 0. The addresses that we advertise to the network, which is currently none. The bindings, which is where we're listening to, which is basically IPv4 and v6, localhost. The default Lightning port is 9735, which is actually the Unicode code point for the Lightning symbol. So that's the port that we self-assigned for Lightning, for the Lightning protocol. It shows the version, the block height we're on. Reg test is 333 blocks in, what network we're on, how many fees we've collected. So that's sort of a nice little summary of how your node's going. Now this is going to be really painful to type, so let's create some aliases. We'll do this one, L1 to Lightning 1, and that to L2. That's going to make our life just a little bit easier. Now, we should pimp our node a little bit. So what we'll do is we'll do L1 stop. We'll stop our node, and we will edit the config file. So we might as well tell it that we're going to be in reg test. We will tell it that we want log level debug. Now, log level debug is really spammy, but it's good for like trying to figure out what's going on. But we'll also tell it to log into a file rather than spamming our console. And we'll tell it to put it in temp L1 log. Let's set the color. Anyone have a suggestion for what color they want? Everyone likes red, right? All red, no green, no blue. And an alias. So we can pimp it out with an alias. Up to 32 bytes can be UTF-8. Let's call it. Anyone, do you want to type a suggestion for an alias name? Satoshi. Okay, cool. Not very original, but you win by being first. Okay. Now there's a really important option which you should always run when you're developing against this stuff, which is to disable deprecated APIs. So our JSON API changes sometimes, and what happens is we give it like at least one major version, and ideally 6 to 12 months before we remove old options, so that your users don't get screwed over when they upgrade. But when you're developing, you should always disable all the deprecated APIs to make sure you're not accidentally using one. So by allow deprecated APIs equals false, it gets rid of any JSON APIs and other APIs that are now deprecated. So you should always put that in your config when you're doing testing. Okay, cool. So let's do, let's restart our node by doing lightning D. Where were we? Okay, blah, blah, blah. We no longer need any of these options except to tell it where the configuration directory is. Cool, it's much more quiet now, which is nice. One get info shows us there. We've got our alias as expected and our color, and that's all pretty good. Now, I will note that there is actually pretty good manual pages. Lightning D config, for example. Config. If it's not installed properly, you'll need to do manual. or should I just type it? Hold on, man lightning dconfig. This should work. Okay, there you go. This documents all the options, you know, that you can use, and there's a whole heap that we haven't addressed, right? I talked about the difference before about addresses and bind addresses. So this is something that people always confuse, so I want to address it now. When you gossip on the network and tell people about your node, you give them the address to connect to. Now, by default, Lightning tries to guess what that is, right? So it kind of like binds to port 9735, and then tries to figure out, is that like a public IP address, or is that like a private IP address? Is it loopback and everything else? If it looks public, then it decides to advertise that by default. But you can have weird setups with proxies and NAT and everything else, in which case you need to specify explicitly what addresses you want. And there are 3 ways of doing it. One is to say address equals, you know, IP address port or a Tor address or something like that. And that means, right, that is the address to bind to, but also if it's not obviously wrong, like it's a loopback address, then that's also the address you should advertise. But there's also an explicit way of saying, no, bind to this address and advertise this other address. So you can specify bind addresses and advertise addresses separately if they're completely different. So you can say announce this address, but bind to these addresses, and you can have multiple of those. Okay, so, and as soon as you specify any of those, it turns off the automatic address stuff, right? So you won't get it binding to port 9735 at all. You can turn auto listen back on by specifying auto listen equals on. So sometimes you might want that. You can also set the proxy if you're using Tor and stuff like that. So there's a whole heap of options in there that you can read at your leisure. So, okay, right now, let's start another peer. We said we're going to have 2. L2. Okay. We watch it fail, all right? And it fails because it's basically by default trying to use the same port. So we obviously need a separate port for that. Now, there is an extension. You can actually tell it to bind, instead of to an IP address, you can tell it to bind to a file. So what we do is we do --addra equals temp L2 peer. And that means you'll have to be actually on this machine to even connect to it as a peer, which can be really useful. Now, at this point, we will see a bug, right? When something bad happens, you'll see a backtrace like this, all right? These are the things that usually you send on our bug tracker, or you connect onto IRC and you say, hey, Rusty, look at this paste bin. Here's the bug that we found. And I found this the other day while testing. So I am going to briefly show you, if you're feeling up to it, like you've got a bug and you want to chase it down, how we do that, right? If you remember, we built with the development options. So we can actually add to this dev debugger equals, and then you can tell it what daemon to debug. So anything that contains this string, the connect daemon contains connectd, so we can say that. And what it will do is, by default, it runs up a GNOME terminal with that, with GDB in it to attach to that daemon just after it started up. Now, because Ubuntu tries to be secure, you have to do this. Because I have rebooted, you need to do echo 0 sudo db of. You need to put a 0 into this number. There. If I typed it right. Okay. Cool. Okay. So let's try that again. Kill that. Kill that. Okay. This time GDB will manage to connect. Okay. So GDB is connected. We continue. There we go. Okay. Oh, okay. It failed for a different reason because we didn't have the port that we told it to use. L2 peer. Delete that and try again. Close our window. Okay. Here we go. This time for sure. Continue. Right. Here we can see it aborted, and we can actually go up 4. And here is the line where it aborted, 997. And we can poke around and see what's wrong. Oh, okay, obviously that's supposed to be false, and it's true. Now, as it happens, this is because I used an unsupported option. And this is a bug that I have a fix pending for, but I deliberately didn't fix it so that we could look at how you would track down this kind of thing. So this allows you to open it in the debugger. You can do all kinds of things, like look around the source files and, you know, go up a level and see what's being called and stuff like that. So in this case, the workaround for this is easy. We do bind to this address. And the reason it's actually asserting is because it's trying to advertise this address, and it goes, hold on, this is a local address. This should never happen, right? So it is a bug. But bind address does what we want. We have to remember to delete the file beforehand. Here, like this. So that's how we can run up the daemon. Okay. It's upset about Bitcoin D. Now the reason that happened, L2, is because we didn't tell it what network to use. So it was trying to connect to testnet. Network equals regtest. Cool. Okay. There we go. We've got junior set. That's our second node. So L2 get info. We have L1 get info. Okay. So we have two nodes now. As you can see, L2's binding address is a local socket there. Okay. Cool. Now let's connect them together. We could tell L1 to connect to. Now, in order to connect to a node, you need to know its key. So you can do a cryptographic handshake. So we say connect to that at the file name, because in this case, it's a local socket rather than an IP address. There. Okay. So that is connected. Now, let's do L1 list peers. Okay. We can see we've got it's connected to L1 and L2 is connected to L1. So you ask each one, they're connected to the other one. Okay. Now this is pretty low level, right? This format here is JSON. The JavaScript object notation, of course, we're going to get spammed by L2. Let me restart that. Let's rerun up L2 with like a log option to kill that. Log file equals temp L2 / log. Okay. Now let's look at list peers. Okay, so currently it's disconnected. Let's connect again. Okay, it's good. So this is JSON. JSON is pretty simple. Key value pairs. We have open curlies for objects, and we have square brackets for arrays. Okay, it's pretty easy to deal with in almost every language. So that's why we use it. The real reason you use it is Bitcoin D uses JSON. So I went, okay, let's use JSON. Not because it was a deep choice that we were, deeply consider all the options. It's just, that was what Bitcoin D did. So, okay, we fired up our peers. We've got them connected. Let's create our first plugin. Okay, now I'm going to do something really dumb that you should never do, which is create a plugin in shell. Okay, and that's just because this is like a really cheap demo. So what we'll do is we will cat greater than temp plugin.sh, right? And it will literally be that, and whatever it gets, it will just put into plugin.log, right? Okay, we need to make it executable. Plugin.sh. Okay, so that is the world's stupidest plugin, right? Now let's run up stop L2. Lightning D, let's run it again. Running up L1 is really pretty easy. We run it with temp L1. Now, you can either specify a plugin directory, and it will try to look for everything that's executable that looks like a plugin in that directory and fire it off, or you can actually specify a specific plugin, which is what we'll do here. So our plugin is called temp plugin.sh. Okay, let's run that up. Okay, there's the old one has died. Now, let's look in temp L1 log. Okay, cool. It hasn't done anything yet. That's strange. What's happening? Okay, let's do PS tree. PS tree again. Wow, I've got a lot of crap. Oh, okay. So what it's doing at the moment, sorry, plugin.log. We told it to dump stuff in plugin.log. It has sent this JSON message to our plugin. Our plugin, of course, is stupid and doesn't respond. So what will in fact happen, if we foreground this, is that after 60 seconds, it will give up on the plugin and refuse to start. So plugins have to respond to get manifest. And get manifest is where the plugin says, okay, so here's what I support. Here we go. There's the failure. Our plugin.sh failed to respond to get manifest in time, and it just went, well, okay, that's something's badly broken. Okay, get manifest should be really, really fast. Okay, so we know what it's going to send us for get manifest, and we can follow our slightly ridiculous example a little bit further, and we can actually respond to get manifest. Okay, so we're going to do this, and then we're going to abandon this really stupid plugin. Right? Okay, so insert. Okay, we need to get the ID. Every JSON RPC command has an ID. So we basically read whatever they send us until we get an ID line, and we go, okay, that's great. I will respond with that ID. And in response to the stuff it's asked us, we tell it what options we support. In this case, dumb option, and what methods we supply, and we call it dumb message, right? Okay, and the rest of anything else it sends, we just put into the log again. Okay. So now let's restart line 1 with the plugin. Okay, actually, let's not do that. Let's do -- help. Here it lists all the options that Lightning takes, and you can see down the bottom, it's added dumb option. It's actually gone out, it's queried our plugin, and our plugin's gone, yeah, we've got an option called dumb option, and there we go. So it gets integrated in the help message. It also adds a new option called, what do we call it? What was it called? Dumb method, right? Dumb method. So we can ask dumb method, which takes an argument, which is x66. Dumb method x66. No arguments accepted. Okay. Oh. Oh, sorry, Lightning CLI. L2. Okay. Do L1 dumb method. Of course, it hangs because, again, our plugin that we've written is complete crap and doesn't answer anything. But if we look, temp plugin.log, here you go. So there's the rest of the get manifest. We sent back a joke manifest. Then it said to initialize ourselves, and then it's handed us dumb method, right? It's sent it all the way through, and it's waiting for a response, which is obviously never going to come. Okay. Now, the reason I kind of like introducing plugins like at the really low level is if you're trying to debug something because something's going terribly wrong, you will see this JSON flying back and forth. You can see it in the logs. You can log it out of your own daemons and stuff like that. So you will kind of get exposed at that level to the JSON that's going past, and it's nice to see. You know, if you manage to screw up and produce something you can't parse, you can look at it and see what's going wrong. So the other interesting thing here is when your plugin gets initialized, so it goes through and it asks all the plugins what they support so it can build up options, and then it initializes them all. And it tells it what directory you're operating from and where the RPC file is to connect in if the plugin itself wants to make JSON queries to the Lightning daemon. So you get those two by default, and usually you read those out. Okay, now, at this point, it's time to stop playing around and write a real plugin. So the standard way to write a real plugin is basically to take the contrib, plugins, hello world plugin, and make it your own. So in this case, we'll call it plugin.py. And this uses the Python library. So you need PyLightning installed. You can either pip3 install Lightning, or you can install it directly like this. So you pip3 install Lightning, or you cd into contrib Lightning and do Python3 setup develop. And that is, let's cd into contrib Lightning and develop. Okay, and that installs it locally. So you've got a local version of it running. Cool. Okay. So now let's L1 stop, Lightning D, dash plugin equals plugin.py. And this is the default hello world plugin, I'll run in the background. L1 help. Here you go. You can see it's got a hello, and that's the hello plugin. It just provides a hello function that echoes back what you want. So, okay. So this is important. Plugins from a user point of view, plugins are part of C Lightning, right? They have exactly the same power that anything has that's built into C Lightning. In fact, that's one of the reasons we moved payout. Over time, we're going to move more stuff out to plugins. And in particular, we're going to enhance the RPC API so plugins can do more powerful things. That's something that's actively going on now in development, which is why it's good to look at master. But it also means if you're writing a plugin and you want something, it's a really good time to ask us and say, hey, I wish my had a plugin that could do this. Can you add like an RPC call? We can discuss what's the best API because we're going to have to support it for a while to make plugins more powerful. So eventually, like most of the power of C Lightning is going to move out to plugins. Okay. So we've got like this kind of this little plugin in Python, which is probably the easiest way to write plugins. And basically from Lightning import plugin, it starts up a plugin, and you have these annotators that say what methods you have. This is the hello method. It has some documentation. It gets a greeting option, and it basically just prints it straight back, right? So here's what happens when it initializes. It doesn't do anything except print out hello world. You can also have subscriptions. So current subscriptions are basically things that you tell in your manifest. You say, hey, Lightning, I want to know when these things happen, and it will call you and notify you. Currently, they're connect and disconnect. There are a lot of others coming to show you what happens when peers connect, and you can do whatever you want there. We don't really need those subscriptions. We can delete them. And here's an option, for example, -- greeting defaults to hello and tells you the greeting it should use. So you can run lightning d -- greeting. Anything that you can specify on the command line, of course, you can also specify in that config file. So instead of -- greeting, you would just give greeting equals, right? Config file. Okay. So one of the coolest things about Python is you can do this, and from Flask import Flask. We want to do a web service. We want to provide a web API, so import threading. So we do that, and then we go, and I completely cut and pasted this from like the really good documentation for Flask. Basically, Flask is basically a web server inside a Python program. So you turn debugging off, and then you say, okay, then you tell it what to serve. So you annotate again, route / basically if they access the root, then you go hello world, and you print, return hello world. Let's just make the indent match. Okay, and then inside our thread, when we get initted, we will do, we'll actually start the Flask thread as a daemon. Okay, cool, like that. So that basically turns it into a web server. Now, remember to make it executable. In this case, we copied it from the hello world thing, which is already executable. Now, you can run up plugins manually, right? This is actually how they get done by Lightning D, but for debugging, it's really cool to run them up manually. Okay, the process of plugins throughout the lifetime of Lightning D, or they invoke a new process each time there's an event. Okay. Oh, and is there anything from the community plugins to get rated on trustworthiness? Okay, let's answer them backwards. The processes for plugins are connected to the lifetime of Lightning D. So Lightning D will start them up, and Lightning D will shut them down, will kill them off, right? Which is actually really useful for a whole heap of things. It means Lightning D is really in control. And if they obey like the directory and stuff, you can run up multiple Lightning Ds, and they should all live happily in their own directories and things. They can have their own configuration file. So there's two ways to write a plugin. One is it could have its own config file in whatever format it wants. The other way is to just tell Lightning D what options it wants, and then Lightning D will do the parsing for it and hand those options through. Depends, I guess, on how sophisticated your plugin is, but certainly I prefer the integrated approach, at least to start with the plugins, which is what I've done here. There is actually a Lightning plugins repo that contains a few plugins that people have written, but we haven't formally gone through as far as like doing community vetting for plugins and stuff. That kind of thing will come with more security, later on. As things get more sophisticated, there'll be like more vetting of plugins and things. But for the moment, it's like, you run a plugin, you've got like $3 on your, three test Bitcoin on your test node, and somebody compromises it. Well, that's okay. Right? We're still in that kind of reckless phase with Lightning. So obviously, caveat emptor, if you've got like a serious amount of money on your node, you should be reading through the plugins that you're downloading and furiously running. But because you can specify a plugin dir, you can just drop them in a plugin directory. And in fact, there are options in that you can specify to blacklist particular plugins and not start those up. You can also specify multiple directories and stuff. So I expect like there to be a lot of growth in plugins, and I expect especially people from this call to kind of write plugins and go, oh, I can't do something because there's not a powerful enough API. So we will add that pretty much on demand. And that's happening at the moment. Okay, so let's run this up manually. So basically, in this case, we are Lightning D invoking our plugin. So we need to hand it that string, which was the JSON string about get manifest. So we need to ask it to get its manifest. And we go, here's one we printed earlier, so we'll just cut and paste that in. Okay, there you go. It gave us the manifest. So it's telling us everything about itself, right? And then we need to tell it to init. Now we also had one of those because we spat out what we got given before. Here we go. Here's init. Okay, cool. Now, it's actually dumped a log. It's actually using the logging stuff to dump a backtrace because obviously I committed a typo somewhere. What did I do? Keyword option, dump option. Okay, so I screwed up. Let's this. Where did I mention dump option? Oh, okay. So that was my fault. That thing I cut and pasted in was not the correct value. I fed it a dumb option here, option dumb option, which it didn't say it was interested in. So naturally the plugin freaked out. So let's try that again. We'll feed it. Here's your get manifest call. And here is your options call. I will skip the bit that you wouldn't want and give you that bit. Okay. Cool. Okay. Now Flask printed out some crap, and it says it's running on localhost. Okay, so let's find that out. 127.0.0.1:5000. There we go. So there's our plugin running a web server inside it. Okay. Cool. So you can debug it that way and tell that it works. There is a trick on the Python plugin stuff if we take out auto patch equals true. So the example does this. You probably shouldn't do it anymore. There's an environment variable when Lightning runs it that tells it to auto patch. Otherwise, it doesn't. So that's why we got, instead of a standard backtrace, we got it in log format. The Python plugin infrastructure actually captures everything your plugin writes out and turns it into a log message, right? That's not so useful if you're running it manually. So turning off auto patch makes that better. Okay, so it seems to kind of work. Let's run up L2. Here we go. Plugin. Did I stop that? L1 stop. No, I didn't. Okay. So if we run up our plugin now, it should be running. Yep, it seems to be running still, which is good. If we look into L1 log, right, there we go. Okay, so Flask is actually logging to standard output, which is getting turned into a log message, which comes through here. So we can see our get request. Ooh, let's tail-f that and watch if we see a reload. There we go. We see another one. So that works pretty nicely for us. Obviously, we can control logging levels and stuff like that. We're doing debugging logging, so we're getting pretty much everything that the plugin prints out at this point. Okay, cool. Okay, now we should probably do something a bit more useful than, printing out hello world. So what we're going to do is when they hit that URL, we're going to give them an invoice, right? And so instead of this hello world function, we're going to do something a bit better. Okay, so buy our plugin. So where's our, yeah, so instead of this function here that prints hello world, let's do something a bit more ambitious. Unfortunately, I indented this in my notes. So. Okay. Now, when you create an invoice, people often ask this, there's this label field that has to be set. And it has to be unique for the invoice. And you have to set that. You're responsible for setting it. And the reason that exists is that there's a race condition. If you say to Lightning create this invoice, and something goes wrong, you then have to know whether or not the invoice actually got created before it died, before the machine caught on fire, or not. By forcing that uniqueness constraint, it means that if you retry, it'll say, no, that already exists. You can't do it, right? That's why you have to provide a unique label. It's for robustness. But for little things like this, we don't care. So we've just grabbed 8 bytes of randomness, and we've just thrown that in as the label in hex. So let's do that. So that serves the invoice. We'll stop our one, we restart it. Okay. Right, and let's look at what happens when we hit reload. Boom, something bad went wrong. Okay, let's look in our log. Here we go. We have got the Python backtrace, right? Name secrets is not defined. Okay, there we go. Rusty screwed up and didn't do the import secrets line at the top. Okay, bye. Import secrets. That wasn't actually the bug that I expected to hit. So let's do that again. This is the bug that I expected to hit. Here, we run it up again. We hit reload. We get an internal server error. And we'll get a more useful bug report from the logs here. Okay. This line here is the important one. We didn't provide a description to the invoice, and you have to do a description. So description gets embedded in the invoice, and it describes what you're offering the person if they pay, right? The spec says, it's completely unenforceable, the spec says it's supposed to be descriptive, right? So it should actually describe what they're getting. If you're selling, shoes over the internet, it should be, shipping shoes to blah, to this address or whatever, or this number of shoes, or whatever it is you're doing. It does have a length limit of 640 characters, but that should be enough for at least to provide a comprehensive summary. So let's fix our plugin. Now, because the plugin's already running, we have to restart every time. So editing it is not sufficient, but let's put a description in. Description equals get a better description. Okay. Get a better description, but description. Okay, let's do our stop and start dance again. Okay, this time. Oh, this time it was supposed to work. Let me check our logs. Dict is not callable. Oh, yeah. Okay. I did actually fix this, and then I rebooted my machine and lost the fixes. So, okay, let's blah, blah. We return invoice. Let's return invoice brackets Boltathon. So this actually returns a struct. Invoice is kind of a. We just want the Bolt-11 part of the invoice because it contains like a whole lot of other information, which the user won't care about. So we stop. Start again. This time for sure. There we go. Okay. So it's created this massive long invoice. Right. You can tell from the start it's an ln BC. So BCRT is the reg test network. Okay, we have 5 more minutes. Okay, so let's decode that. There's a cool tool in here called DevTools Bolt-11 decode. There. Okay, here we can see what currency, timestamp, when it expires, who is to pay to, which is our node, the payment hash, how long it's got, sorry, min final expiry is how many blocks you need to have remaining on the payment when it occurs, how much it's for, 24 millisatoshi. This is redundant. We also put it out as MSAT format, and the description that we put in. And then finally the signature, which proves that this node indeed issued the invoice. Okay, that's pretty straightforward. Of course, we want to test that we can actually pay it, right? So we've only got 5 minutes to go, so I am going to very quickly run through this, which is, let's do our connect, L1 connect. Yep, we may have already been connected. L2, let's get an address from L2. Bech32 address, that's fine. Now, you need to do Bitcoin CLI bridge test, generate, send it to address. Let's send ourselves 10 Bitcoin. There we go. Now we need to mine that. Bitcoin bridge test, as I said, can actually address one. You can tell it to mine however many blocks. For reg test, we do everything with one block, one confirms, because that's enough. So there we go. We get it to generate something. Now if we do list funds, after L2 is caught up, it should see, it polls every like 30 seconds or so. It will eventually catch up with blocks. Do get info. We'll see this on did I correctly send to that address? I did. Okay, I did generate a block. There we go. Okay, cool. We've got confirmed payment. Value in millisatoshis is like a crap load because it's 10 Bitcoin. So there we go. L2 has funds. Now L2 needs to fund a channel. We need L1 get info, L2 fund channel to that one. Let's fund it for 0.042 BTC. Okay. Oh, now because it's on reg test, it can't estimate fee, so we need to give it like a fee rate, which is like 253 per kilo. Okay, there we go. That was like a minimum fee. Slide through. Then we need to generate another block in order to get that mined. So we generate another block. Thank you, Bitcoin D. And then if we do L2 list, L2 list peers, there we go. Okay, so it's got more information than you could ever want to know. Now the list peers has a channel. It's awaiting lock-in. So it's polling Bitcoin D every 60 seconds to say, hey, does anything come through? There we go. Funding is locked. Cool. So now we should be able to pay that invoice. L2 pay. Let's grab that invoice. There we go. Okay. It's complete. And if we do L1 list invoices, we see our invoice. You can see an early one that I made while testing. There we go. This index is paid, and the amount, description, everything we want to know about it. Okay. So what I actually wanted to do with this is do something more interesting. And we are pretty much on our time limit. So instead of showing you, I will upload this. I'll tweet out the URL for where I put it. I actually extended it to, rather than just producing an invoice for 21 millisatoshis, it actually embedded in that in the payment pre-image. It actually embedded 24 bytes of text. So either they're directly paying for 24 bytes of text. The way payments work is the invoice promises them to give them a secret if they pay. And that secret is normally a random number. But in this case, I used 8 bytes of randomness, and the other 24 bytes, of course, it's a 32-byte secret, I actually put a text field in there. And this is kind of a cute way of basically, rather than having to separately deliver something, you can deliver it as part of the invoice flow. Now, 32 bytes is enough to hold a secret key, for example. So it could be you give them a file, and basically when they pay, they will get the decryption key. And the decryption key actually will be the pre-image, that secret that you promised them. In this case, I used 8 bytes of randomness to make it harder to guess, and then just 24 bytes of some text. That could be done for some kind of, pay to reveal text kind of thing. And in fact, I wrote a plugin to do that for you, to do the URL query. So it added a get word. You just did blah, L2 get word. The plugin itself then reached out to the URL that you gave it, fetched the invoice, checked that it was a sane amount, and paid it. So I can upload those plugins somewhere if people want. So I think we've hit time. Did anyone want to ask any specific questions before we wrap up? Okay, what language to write plugins in? Do not write them in shell, no. Python's good. C has, the pay plugin is written in C, and there's a lib plugin for C. There's also some Go. Nifty Knee has written some Go infrastructure, so you can write it in Go. I didn't do that because I'm not a Go person. I'm more comfortable with Python. But really, anything that I can understand JSON, you can write. So any language really would work. C#, if somebody wants to go and do C#, the problem is that C Lightning itself runs on Unix-based systems only. So we don't have any Windows support. So C#'s not exactly top of our list. Is it possible to do something like HODL invoices? Yes. Okay, so this was always something we wanted to do. So for those not familiar, HODL invoices are what Lightning Labs call them, but basically it's a just-in-time delivery system where you spray out all those invoices, and actually when they come to pay it, you go, oh, do I actually have the thing they're paying for, or do I reject at this point? And for some models, that's much better than reserving when you hand out the invoice. Even though invoices have an expiry, you may well want to just spray out a whole heap of invoices, expecting only a small number of them to come back. So you don't want to hold stock based on the invoices, but on actual payment. It can be bad UX though, because of course they got an invoice, they go to pay it, and then you go, oh, sorry, no, that didn't work. So we have a thing in plugins, which I didn't show here, called hooks. And a hook is like a notification, except the whole thing is waiting on the plugin getting back to you to say, yes, it's good, or no, it's not good. So subscriptions are for notifications where you just get told stuff's happening, but hooks actually show you actually blocking. And so a hook on payment receipt is really important for this. So then you'd write a plugin that registers with that hook, and when it actually comes in, it goes, oh, should I actually honor this payment now? Yes, it matches the invoice, but maybe there's some other reason that I don't want to. So that would allow you to do hold invoices. Maybe you just hold off for a while until something else is lined up. And for complex systems, that's actually quite important because you may have a whole CMS system around it. Yes, .NET Core can definitely run on Linux. So yeah, you could do C# on Linux. It's just a question of it wasn't the most popular language for people to use on Linux, so that's why there's no C# plugin lib. But it would be pretty easy to write. Basically, if you could speak JSON, you just handle those bits, like handle the registration for them, and it's pretty easy. It's actually pretty easy to write in any language, just natively. But it is nice if you've got a library that does all that infrastructure for you and registers your options and does all that stuff, rather than having to do it manually.
All right, thank you so much, Rusty. This was fantastic. If people want to reach out to you and ask you more questions, where can they find you?
Yeah, so Rusty Twit on Twitter is usually the best way of doing it. We also hang out on both the Lightning Dev and C Lightning IRC channels on Freenode. So Lightning Dev is generally for like general Lightning development discussion, protocol discussion stuff, and C Lightning is specifically for C Lightning questions. And of course, my email is pretty easy to Google as well, rusty@blockstream.com or rusty@rustcorp.com.au.
Okay, thank you so much. All right, our next talk is Justin Camarena from BitRefill. Tickets are still selling, so if you want to grab a ticket before his next session, that'd be awesome. All right, thank you guys all so much for joining us. We'll see you later, Rusty.
Ciao.